Good evening and welcome to Physics with Mirror Electricity Explained for Trident students in double science, namely me. This is featuring weird analogies to explain, created by Joe and Frank Lewis Gaga. Now, today we'll be studying physics in relation to chemistry, which basically has nothing to do with physics. First of all, we start off with electricity is a negatively charged particles that move or build up. First of all, using our useless analogy, the negatively charged particle is always a man, and the positively charged particle is always a woman. Don't ask me why, that will be explained soon. Now the world is full of an iron core. Now this is full of a whole lot of positive stuff. Women. And around the outside, where we are, is a whole lot of negatives, as well as positives, but you get the point. Now, these come to Earth in lightning strikes, and when you get shocked by an object because you've touched it, and then it's gone through you to get to the Earth world. Because, now it all makes sense, the man is always chasing after the woman. Now, the way electricity works is rather slow, actually. It's not like you're chasing, more than like taking a little stroll. Now, men like to work together in a team environment. Don't get why. Okay, they're not very independent. Now this little man here, it mostly works with metals because they have a free chair, which basically means there's a lonely little man over here. It means there's a whole lot of hot chicks in here, and this little man over here. Okay, so he comes along and he goes, ooh, hot chicks, I'll have a look here and then I'll continue on to my way. And he goes, okay then, I'll start my journey. And he goes over here and he goes, ooh, distracted by hot chicks. And he goes, well, I'm waiting for my wife, so he jumps off. And basically a continued cycle until they finally get home. Now, their home is called a battery. And I've skipped millions of pages, hang on. Don't use giant cards for presentations, stupid. Okay, so as explained here, attraction. There is a man and a woman. Unlike real life, in the world of electricity, men always love women and that's it. Now the woman never moves. The proton will never move. Positive charge stays where it is, where it's supposed to be, in the kitchen. The man runs into the kitchen. That's just how it is. Now, we'll think of positives. They don't like to be around each other too much. So they're like two women who are turned up in the same dress. They don't want to be together, they sort of move apart. Now, two negative electrons don't really like hanging together either. So they're going to go to a woman electron because, guys are obsessed with hot chicks. So, negatively charged particles are obsessed with positively charged particles. These two feel kind of awkward together. It's like having two guys in a room all by themselves when their parents go, oh, how about you have a little chat? Like little kids do, because we're friends, so you can be friends too. That doesn't work. Okay, so now we move on to the important stuff about circuits and stuff. I'm not really going to do anything on symbols because really you should remember those because they're pretty simple. I mean, a circle with a cross through the middle of it. Okay, we're going to move on to what are amps. Now, amps are how many little men run through the circuit. The circuit is like a road. They need to get to the kitchen. Now, the way amps are measured is by using an ammeter, which is this symbol here. Okay, I know I told you I wouldn't do anything on symbols, but, this one's pretty obvious. An A, you get the point. Okay, now, how an ammeter works is it has this little dotted line right here, near the kitchen, or wherever you put it. Basically, it has a dotted line wherever you stick it. And it measures how many men run past this line in 1 second. In 1 second, past this line. And the way it works is a man runs around the track, run, through these thingies. Now, these things are like jumping hurdles for them. They're a little bit more hard. To be perfectly honest, they don't really want to jump the hurdles, but, this wife's made a sandwich for them and has already run them and says, honey, you're late for dinner. So it's pretty stressful. They have to get home to the wife. So they're running along through this, come up here, and look, sandwich. Okay, so to get here where the sandwiches are made, I don't know why I've drawn this woman over here. I think I just got a little bit obsessed with sandwiches. Okay, so you take a meter with your ammeter, and you see the little running man here. So if there's only one man running per second, it doesn't really work like that, but for this case, we're going to work with one man per second. Okay. And you take the little measure here, not where the kitchen is, just where the ammeter is. I got a little bit excited. Okay. Okay, with this thing here. Okay. This thing is here, and it goes, there's one man through here. And then he runs and he jumps off the hurdles, and then you take a measuring from here. And there's still that one man. Now that's the thing that a lot of people get confused about, is why is there still one man going through the amps after he's jumped over all the hurdles? You think, oh, he goes through a light, so he's going to turn into heat and all that sort of stuff. But he doesn't. He still stays in the wire, okay? It's like a man running a race. Yeah, he's running a race, and then he jumps the hurdle, and as he jumps the hurdle, he sort of knocks it off a bit. Okay, when he knocks off the hurdle, that's creating light and heat and all that sort of stuff inside the wire. He still keeps running the race, okay? He still keeps running the race. Now, I'm going to move on to the next piece of paper, which might be a bit dubious, because I just ripped my other one off accidentally. Our next one is voltage. Voltage is the sandwich of energy. It is basically how much energy a particle carries, how many sandwiches a man has. Now, he collects these from the woman at your power supply. This little liney thing here. Nobody understands why it's drawn that way. It just is. Okay, so he's got his sandwiches, and he's running along, and he gets to here, and as soon as he hits this little light here, he's like, eh. So he has to eat a sandwich to get a little bit more, to get enough energy to go through that. Now, when he gets home, it's like having a wife, definitely. You can't have sandwiches still left in your bag. This man is going to use sandwiches, all of his sandwiches, along the circuit. There's not going to be anything left, because he doesn't want to get in trouble. Now, the way that volt is measured is with this voltmeter here, this V, I know, quite predictable. This V, he takes a point from here, and he says, oh look, this man has 5 sandwiches. He hits the light, and then he's got 2 sandwiches out the other side. Now, the way a voltmeter works is you connect it in parallel, we'll talk about that later, in parallel, and he takes a measure from here, says 5 sandwiches, and then he goes 2 sandwiches. So, your voltmeter's a pretty logical guy, and he goes, 5 negative 2 equals 3, which means that there must be 3 sandwiches eaten in the time that this has been here. Now, yeah, I understand too there, but you know, it's just an example. Don't ask anymore because I'll get confused. Now we're going to move on to combining cells. Now, cells. This is not biology. Remember, this is physicsy, electronic stuff. So cells are not the stuff in your arm. Well, that's not attractive. They are what are called batteries. Everybody knows them as batteries, but actually they're cells. So welcome to the top 4% of the world that actually realizes that they're not batteries, they're cells. Okay, now that we've got that sorted. This, I know, I said something about symbols and then I drew lots of them. That's really confusing and makes me look like a doofus. But this is your single cell. This here is a cell connected in parallel. Now, here's another useless analogy for you. It's not in parallel, it's series. I just confused you there, so that was a test question. This is a series because it all goes along and it just goes on and on and on and on and on and on forever like salt and straight. Now, the way this works is we have our man. Our man has no sandwiches because this is a power supply and he's run out of sandwiches because if he has any sandwiches there, he's in heaps of trouble. Okay, so he's running along, and he hits here. Now here, he sees his wife. Where's the sandwich? Let's get this. So he ends up with 1 sandwich here. But then he runs along and, there's his mistress. Yeah, that's right, somebody else's wife. And he gives him a sandwich too. And he's like, oh, now I have 2 sandwiches. Great! And then he runs along, and hits another power supply. And he's like, yay, my 3rd mistress. You're hotter than all the rest of them, so I don't mind. Okay, that's okay. So he takes another sandwich. And when he runs off, he has 3 sandwiches. 1, 2, 3. Okay, so that is how series works. Series is basically a really slutty man. As you can see, my sandwiches are getting worse and worse as we go on because I'm getting bored of drawing sandwiches. Now we'll move on to the parallel circuit, which I Have drawn here too. Oops. Okay. The parallel circuit is arranged a little bit differently. Here I got a little bit bored of drawing little men, so I just drew a symbol there. That's a man symbol. It doesn't have anything to do with electronics, but that's still a man symbol. Okay. Now parallel, it sort of hits a little road here. Parallel is how you get innocent, lovely, kind men, okay? If you set them up with a road, a pathway to get to you, like saying, hey, guess what? I like you, I'm interested in you, come visit me at my house and have a sandwich. Then they're gonna come to your house. Unlike these nasty mistresses who stick themselves in lines. Okay, so a parallel is an innocent, lovely, nice person. So he comes along, and there's three of them. So one of them goes that way, to his wife, Judy. This one goes to June, and this one goes to July. And I sort of got a little bit unamended with it. Okay, so he goes over to Judy, and he goes, and I got bored of drawing kitchens and stuff. So, and he gets a sandwich from here, and then he goes, here, come on, and he goes down, back there. You're thinking, why? Why would he leave? Well, guys need a bit of space, okay? They need a bit of space. And then June comes along, June's husband, gets a sandwich and comes through here. And here, July gets served with his sandwich and comes up here. And now three of them are standing all here. But unlike the slutty man, they end up with one sandwich each. So, we understand, parallel is nice and kind, and they end up with one sandwich each. But it means they all get to visit their house first. That takes a lot less time. So that's how a parallel one works. Now, we're moving on to another piece called resistance. I drew a squiggly there just because, I was bored. It looks like this lovely box thing. It's pretty uninventive also. The way resistance is calculated is by this lovely triangle over here, which you can't see because I'm bending the cardboard, but I'm standing on the wrong side. Okay, V, that's for voltage, as we've worked out. R, well, it's pretty obvious, it's for our lovely old resistance. And I. Guess what? That's amps! Yeah, that doesn't make sense either. That's what I thought. But you know what? It's not my choice. It's been hundreds of years ago that it's been like that, okay? I will think of that as for idiots. Idiots, amps. There we go. Same thing. Not really, but it's still confusing. Just remember it's idiotic for amps. Okay. Now, the way this triangle works, in case you haven't been introduced to it, because you're not a Trident student, like, why would you even watch this if you weren't a Trident student? Okay, if you weren't me, why would you watch this? It's stupider. Okay, so the way this works, volts equals resistance times I. Now, I haven't even told you what resistance is. How forgetful of me. Resistance is how much energy it takes to get through here. So you have a little piece of wire. You have a light in there. It's how many hurdles it has to jump. Now this is measured in ohms. Ohms. Which sounds stupid. Ohms. Okay, so that's how many hurdles there are over hurdleness, man, speed, whatever. Think of your own one. And it's named after a person, so you have to have a big O. Big O. And the way this works is basically there's a little car and you're a little man and he goes and he goes jump over the hurdle, jump over the hurdle, jump over the hurdle, and he uses a whole lot of sandwiches. Now the way you calculate resistance is by how many sandwiches divided by how many people there are. I don't understand, there's no analogy for that one, so don't ask me. So you put, yeah, you do that. Okay. So that brings us back to our lovely triangle. Resistance, kind of sucks. Resistance is always going to be equal to something that I've forgotten. Call me back later. Okay. Well, I run out of cards and I run out of time because I'm bored now. Electricity, it's boring. Oh, we can talk about static electricity. Static electricity is basically you have your pretty little man. Hey, man. And he's like, I want to jump over here. And it doesn't work. Can't reach it. Basically, he's sitting there going, woman. Okay, I'm going to talk about static electricity another time, because this one's sort of failed. Anyway, I hope that helps you out with a little bit about your electrical stuff. And if it doesn't, well, this has been a waste of however long I've spoken for. Hey, have fun and keep studying.